Doesn't end, does it?
No. That's why I think you should drop a test.
Yeah, this is the first slides. Okay. We're going to be talking about how they name muscles and some of the structures and that sort of thing right now, but it's pretty short. Then I'm going to go over the muscles of the cranium and the eyeball there. So it'll be pretty short night science. We have 3 more labs after this. We'll go over the arms and legs and the pelvis. We should finish that plenty of time and have time for like a practical test before the real test. And so, but as far as your lab, it's going to be all models. Okay, so we're not going to have any like lecture type questions, Saratosis type questions, blah blah blah. But anything on the slides is fair game for the lecture. Okay, and you will have, well, I say it's not all models. You might have a sticker on the biceps muscle here, and it says, how did this muscle feel pain? Okay, and I'll explain what I mean by that here on this slide. Okay, but most of it, don't ignore the other models either. See the models over here, the models, the red man there, and the one in the corner. All these are fair game for stickers and pointers and blah blah blah. So, we can find models for every one of the muscles that are on your list. So I'll tell you which ones you might be able to ignore here. But let's just go ahead and go. Okay. Luckily, there are a lot of muscles. That's 600 of them. And luckily, most of them come in pairs. Okay, so you can cut that number in half. And you don't have nearly 300 on your list, okay, because we're ignoring some of the small muscles in the hands and feet, the muscles that do that, for example, okay, that's not on your list. Many of the muscles in the throat, the swallowing muscles, and the voice box muscles, and the hyoid, that sort of thing, many of those are not on your list. It's mainly major muscle groups and big muscles. And there's several, half dozen muscles in the face that you're not responsible for, okay? But some of them you are, and I'll go through those tonight. So this is basically, a lot of muscles are named fairly logically. I mean, you've never heard of this muscle, but what do you think the flexor pollicis longus does? Flexor pollicis longus, you're right. Flexor. Okay. A lot of muscles have logical names like that, so that helps you remember them for one thing, but it also tells you what they do. Okay. When you know them, you know where they are. Okay. If you say, where the flexor pollicis longus, where would that be? Well, it's certainly not going to be in the foot. Okay. Okay. Vastus, large. You have the vastus lateralis in the quadriceps, and the vastus medialis, the big one here. Maximus, we have the gluteus maximus, big muscle of the butt region. So that's named for its position and its size. Okay. Longus, I just said the flexor pollicis longus. It's named for its action, okay, and its position and its size. It's long. Okay. So, and the minimus and brevis, you can gather from that what they're going to mean. Brevis just comes from the same word as brevity or brief. Okay, it's the Latin for short. What's an example? Well, the flexor pollicis brevis. That's the opposite of the longus. Okay. Shape, the deltoid name for its shape, the triangular shape. Okay. The rhomboid here, there's only one rhomboid in the body. A rhomboid is a sort of a rectangular shape that's been kinked like this. So they're still all parallel, but you've got angles now instead of a square. Okay. And that happens to be the muscles that run from your scapula, and it runs up like this and attaches to your spine. So what it does is just pull your scapula back together toward the spine. That's your rhomboids. Okay. Yeah, right here. There's your rhomboids. Okay. That's just an example. We're just going through some names right now. Latissimus, wide. The latissimus dorsi runs all across the back. Big muscle right here. Okay. And it just tells you that it's wide and it's on the back. Dorsi. Okay. Teres, meaning round, comes from the same root as terrestrial. The teres major and minor. You have right on the bottom part of your scapula, you have the teres major and minor muscles right here. Okay? One goes on the inside and one goes on the outside. They externally and internally rotate the humerus. Okay? trapezius, that's the big meat of your shoulder. It's a big back muscle right here. Okay? So it runs all the way from your occiput down about mid-back, and then runs over, attaches along the scapular spine. So that's a big muscle for pulling your shoulders up, okay, like that. Okay? And you probably heard about people talking about doing trap pull downs, working on their traps. That's what you're doing. It's the meat right in here. That's where the trapezius is. It pulls the humerus down. So, rectus, direction of fibers. Rectus just means straight, like when you rectify something, you fix it or straighten it out. Okay. There's several rectus muscles. There's the rectus femoris, tells you it's the straight muscle in the thigh. Okay, right here is part of the quadriceps. You have 4 rectus muscles around the eye. Okay, I'll show you those in a little bit. Let's see, transverse, obviously something going across. And the major one I can think of is the transversus abdominis, which just goes across your abdomen, and all it does is just suck in your gut. Okay. The obliques, again in the abdomen, there's a couple of obliques. There's 2 in the eye as well. They're just going at an angle. Okay, not straight across, but at an angle. The external obliques in the abdomen run like you're putting your hands in your pocket. That's the direction of fibers. Okay? The internal obliques run the other way. So the internal oblique over here works with the external oblique over here to pull your body around, to rotate the torso. Okay? They work in a pair, the internals and the externals. Orbicularis means round, like orbit, so don't forget the R. It's not obicularis, it's orbicularis. Okay? Like an orbit. The round muscles around the eyes that allow you to squint your eyes like that, pull it together. It's a round muscle called the orbicularis oculi for ocular eye. And then there's the orbicularis oris, the muscle that pulls in your cheeks, or your lips rather. And that's the one that gets paralyzed with that shot from the dentist. And that's why you look like this. And location, pectoralis. This is just pectoralis major is the big muscle in the chest here. Runs up to the humerus. You have pectoralis minor up underneath, which is a smaller one. They pull the arm in, so they abduct the humerus and internally rotate it. Okay? We just talked about the gluteal muscles, the buttocks muscles. Brachii, all the muscles in the upper arm here have brachii in the name. Okay? You have the biceps brachii, the triceps brachii, the brachialis, the coracobrachialis, the brachioradialis, okay? They all have brachii in the name, which tells you their location, okay? But the biceps is also the name for its 2 heads. It has 2 tendons and its origin. And let me define origin here before I forget about it. When the part that moves is where the muscle is inserted. The part, say my biceps here, is attached with 2 tendons to my shoulder. My shoulder doesn't move when the biceps constricts, okay? It's the arm that flexes at the elbow, okay? So this is the origin, this is the insertion. Okay? The insertion is what's going to move, okay? So, the supra, infra, sub, where you've already learned some of the scapular muscles. You have the supraspinatus fossa, remember? Well, you have the supraspinatus muscle that fits in that space. And you have the infraspinatus muscle that fits in below the spine. And then you have the subscapularis muscle underneath the scapula. Okay? Right over here. Okay? So, and they're right next to the teres major and minor right here. Okay? So, let's see. Over here. Sub underneath the lateralis, well, that's on the side of something. Number of origins, like the biceps. So the biceps is named not only for its number of origins, it has 2 heads right here, but it was also named for its location, brachii. Biceps brachii. Okay? And same way with triceps and quadriceps. Origin and insertion. If you're going to name a muscle this way, you name the origin first and then the insertion. Okay? Here's sterno, which is sternum, cleido, which is clavicle, mastoid, which is mastoid. Okay? So that tells me that, I'm going to have a picture of it, next one I think. There we go. Here's the sternocleidomastoid muscle. It attaches to the sternum, the clavicle, and the mastoid. It's the major muscle right here that turns your head. Okay, It's the strongest muscle because when it constricts, it's going to pull the mastoid down a little bit, but I can control that. I don't have to turn my head like that all the time. But it's going to pull your mastoid around to turn your head. Yeah.
Is that the one, like when you wake up and you got it?
Sometimes. Yeah, it's common in the sternocleidomastoid, but also in the splenius capitis back in the back, because they work together. Okay, you have a flat muscle in the back here. You can see, especially on some of the other models here. It's underneath the trapezius, the big muscle here. If you take that off, you'll see that the splenius capitis comes in an angle, comes sort of front like this. So it's this one and my left sternocleidomastoid that are going to be pulling my head around. Okay, so they work as synergists, which means they work together. Okay, antagonist means they work opposite. Okay? Like the antagonist of my biceps is my triceps. It does the opposite. Okay, but synergists work together. Okay, I think I was talking to this group about seeing people in clinics where you got the people that were feigning paralysis, and they're saying the whole right side of their body was paralyzed, so they wouldn't move their arm, they wouldn't move their leg, and they wouldn't turn their head to the right. Well, they didn't realize that it's the other sternocleidomastoid that's working on that. So if you're gonna get feign and get disability, you need to take an anatomy class.
So do you always state the origin before the insertion?
Well, the name. If they're named that way, that's how it works.
Oh.
So if you see something like the brachioradialis, you know it starts in the brachial area and ends up on the radius. Okay? So the origin and insertion. Okay? And that just happens to be this muscle right here, brachioradialis. Okay. Yeah.
Which one is this muscle here?
Most of that, well, this knee part right here is brachioradialis.
Back here.
Yeah, but if you look underneath here, these are the extensors of the hand. Okay, so they're the ones that are going to be pulling the hand this way. Right. Okay. That's called the extensor digitorum. For some reason, it's not on your list. Okay, I don't know why, but it's not on your list. But the meaty part on the lateral part there is the brachioradialis. Most of it anyway. Okay, where are we? Adductors. You've got big adductors. There's a adductor pollicis that pulls the thumb into the midline, but you've got big adductors in your thigh. You've got the adductor longus, minimus, and magnus. They pull the leg in, and they all go down and attach to that adductor tubercle, which you learned about on the end of the femur there.
So there's 3 different muscles in the inside of your leg that will
Adduct, more than that. You have the gracilis, and the sartorius will do some of that, and they have other names, but there are 3 that are named for adduction. And then for their size, minimus, longus, magnus. Okay. Extensors. Well, we just talked about the extensor digitorum, the muscle that extends the fingers. Okay. And then levator. A good one is the levator scapulae. It attaches to the scapula and runs up back to your neck and attaches to your spine there. So all it does is lift the scapula up. Okay, along with the trapezius. It's a synergist for doing that. Okay. Levator scapula. It's just like elevator, just take off the E. Levator. Okay. Elevate. And then the masseter is kind of a special one. There's only one. It's on the face. It goes from the zygomatic bone down to the ramus of the mandible. And masseter comes from the same root as mastication, or chew. Okay. And that's how it got the name. So it's known for its function, basically. So that, real quick, is just, you can see the logic of the way a lot of muscles work. So, you'll see 1 or 2 of those on the test. Okay? We'll put a sticker on the biceps or something and say, how did this muscle get its name? And you'll say it has 2 origins, biceps, okay? Brachii, and it's also this location, something like that. Okay? This isn't all that important, but like we arrange the bones in general categories like long bones, short bones, irregular bones, flat bones, things like that. Well, you can kind of talk about muscles in a little bit the same way. Some of them are called parallel muscles or strap muscles because all the muscle cells are lined up parallel to each other. Okay? And you can see why they get the name strap muscles as well. Okay? Then you have the circular muscles that we talked about a lot around the eye, muscles would be like the pectoralis major here. You can see how it starts, has a great big origin, and then it all converges on the insertion here. Okay, that's called a convergent muscle. And
Is there a way, this now sounds like
What?
really weird, but how do you tell which is the origin and which is the insertion? Because-
whatever moves is the insertion.
Oh,
Okay.
great.
See, this is going to move my arm. That's the insertion. My
Okay.
chest is not going to move.
Okay.
Okay? And I don't want you to spend a lot of time memorizing origin and insertions.
Right.
Okay? I know some of the other groups pay more attention to that, but as you learn the muscles, it's going to be common sense. What's the origin and what's the insertion?
Right.
Because you're going to know what it does.
I just needed to
what
know,
moves.
yeah.
Okay? So I think that'll come with experience and time. I don't want you spending primary time memorizing that kind of stuff. Okay? You just need to know the names of the muscles. Okay? Right. Pinnate. This is kind of an unusual configuration. The pinnate structure looks like this, where there's a tendinous structure right through the middle of the muscle here, and the fibers arrange obliquely. They're not running like a strap muscle horizontally. Okay? So they're coming off to the side like this. This happens to be a bipinnate muscle because you got two sets of them. Okay? Well, a unipinnate muscle would only look like this. It would only have the one oblique arrangement. And this is what happens here. My biceps is a regular muscle like this. It would be considered a parallel muscle because all the fibers are running in the same direction. As a matter of fact, every muscle cell runs from the insertion or the origin to the insertion. Okay? That's one cell. And that's why the skeletal muscles tend to be multinucleated, because you have to have DNA available to make proteins in all different parts of the cell. So they tend to be long cells with lots of nuclei in them. Okay? So they do not undergo cytokinesis when you get to mitosis. Okay? But anyway, so this would be something like my biceps. And when it contracts, I'm just going to get the bulge. Okay? The whole thing has to contract so you get a bulge. All right? This kind of thing, and you can get pretty fast movement with this kind of thing. Okay? Whereas with this, it's almost like a transmission in low gear. You can have a lot of these fibers, all of them arranged like this, and if they contract all at once, you're going to get a lot of strength, but you're not going to get a lot of movement of the tendon. Okay, so it's like a transmission in low gear. You get a lot of power, but you're not going to get a lot of movement of the tendon. Okay, and that's what like the rectus femoris is there. And everybody knows that when you straighten out your leg, you don't get a big bulge in your thigh, okay, because the fibers just aren't arranged that way. Okay. Multipinnate would be something like the deltoid. There's actually 3 sets of those tendinous structures, so there's almost 6 pinnate structures that are going through the deltoid. Okay? So that would be a multipinnate muscle.
Excuse me.
Yeah.
You said when you straighten out your thigh, you don't get a big bulge. I don't really understand that, because if you have pretty big leg muscles, then...
Well, yeah, that's another size. Yeah. But just think about it. If you don't have to move your arm too much, and you start to see the bulge in your biceps. Okay, but you don't see much bulge at all when you just straighten out your leg. Okay? Now, if you've got big muscles, yeah, and you resist it, you try to straighten it out against resistance, yeah, then you're going to start to see, muscly bulges. Okay? But the action itself doesn't take much. We talked a little bit about fascia before. At least I've thrown the word out. I haven't really defined it. But to get a handle on it, just think about the white, tough gristle on the outside of a raw steak. Okay? Not really the fat part, but the connective tissue part. Some of you like to cut that off. Well, think of that tough, tendinous-like stuff. That's what the fascia tends to be. Okay? And especially the aponeurosis, which is a word you haven't heard yet. These are flat tendons. There's one that runs across the top of the head. Okay? It's called the Galea aponeurosis. Okay? And then there's one in the middle of the diaphragm. Most of you may not know that the diaphragm is not a big muscle that goes all the way across. Most of it is tendon. It's just a flat tendinous structure in the middle. Okay? So, and it's like a dome. Okay? It's like a dome, so when the muscles constrict, the only thing that happens is the dome flattens out. But that creates the vacuum in your chest, which pulls the air in, okay? You do not exhale with your diaphragm. You cannot force it up, okay? It can only pull itself down, and then when it relaxes, it just goes up when you breathe out. But most of the time, you breathe out with your intercostal muscles in the ribs, the one between the ribs, okay? The externals work just like the external obliques in the abdomen. They run this way, and the external intercostals run this way. And when the externals contract, they tend to pull the ribs up. Okay? The internals are running the other way, so what they tend to do is pull the ribs together, and that's how you exhale. Okay? So exhaling is the internal intercostals. Inhaling is the diaphragm and the external intercostals. Okay?
Interesting.
Speaking of that, like, why is, when they say when you're like hard to breathe, just raise your arms above your head, it makes it a little bit easier for you to breathe.
Yeah, that's probably because it expands the chest.
So it makes it,
Yeah, it just sort of lifts up the ribs. And you're not compressing the lungs as much.
right.
You keep saying internal, external. Are there several layers of
There's
muscle?
2 layers of intercostal muscles between the ribs, yeah. Yeah,
And the abdomen as well?
right. Well, there's actually 3 in the abdomen.
I saw that in the book.
External, internal, and underneath all that is the transversus abdominis. Okay, the 3rd layer next to the peritoneum is the transversus. Okay, and right, they all sort of come to the middle and attach to the rectus abdominis, which are the 2 straight muscles, the 6-pack. Okay? But, I got a joke, but some people. So these are the 2 important names, or at least you should remember what an aponeurosis is. Okay? You should remember the Galea aponeurosis, and this is called the central tendon of the diaphragm. Okay? 1 or 2 of those is going to be on the test, just like glenoid or acetabulum. Okay?
Central,
Galea. Okay? I'm not sure it's spelled right on your
what do you say, central
paper.
what?
And you can't see it here. I should mention also, if you take that tendon and you hook it to the frontalis muscle here over the frontal bone, and the occipitalis muscle here over the occipital bone, if you look at them all together as one muscle, it's called the epicranius. Okay? On or above the cranium, remember? Okay? So it's named for its location, basically.
What was it there when you said?
Epicranius,
No, before.
occipitalis here in the back,
The one on top?
Yeah, over here.
or here. Central tendon of the diaphragm.
Central.
Thank you.
And it's considered an aponeurosis. It's a flat tendinous sheath. Okay? There's 2 more, lower back, big ones along the lower back here. These get torn and cause back pain fairly often. Okay? There's one, a flat one that runs over the rectus abdominis here in the abdomen. Okay? But don't worry too much about these. I don't know what's going on in the test. Just realize that they're there. And then there's a special thing here called a retinaculum. Okay, you haven't heard that word before, but this is what it is. It's a flat tendinous sheath that runs around the wrist, and there's another one that runs around the ankle. Okay? And what that is for is, if you can imagine, if you're really trying to like flex your wrist and push down on something, if there wasn't something here holding the tendons in, they would all flay out. You know, they would come out like that. Okay? So you need something to hold them next to your wrist, and that's what the retinaculum does. Okay? This is the kind of thing you need to slice up when you're trying to fix carpal tunnel syndrome, because the median nerve that goes underneath this canal right here, goes underneath all the retinaculum and comes up through the canal. It's getting pinched in here along where the carpal bones are. Okay? This would be the pisiform right there. And so that's what you need to go in and slice and open it up a little bit to take the pressure off the nerve. Everybody know what carpal tunnel syndrome is?
No?
Hands up, no. Okay, let's talk about it just a second. You see it a lot clinically, a lot of carpal tunnel problems. Some of you have probably had it. But what it is the median nerve. Okay? There's an ulnar nerve, a median nerve, and a radial nerve. The radial gets the thumb. The ulnar nerve gets the little finger and this side of the 4th finger. So numbness and tingling on this side and the little finger, you know it's ulnar nerve. Median nerve is these 2 fingers and the other side of that finger. A lot of people will just come in saying, my hand's tingling and numb, and they think really it's the whole hand. So when you test them, it's really just median nerve most of the time. Okay? So they probably got a pinch median nerve in that capsule in there. And they'll just go in, now it's done arthroscopically, I'm not even sure they do cuts anymore. They go in with the arthroscope and just make tiny little cuts to widen that up there so that you don't get that tingling. Okay? But it's usually from overuse, you know, especially a lot of work on a keyboard or something like that. Bikers tend to get it a lot, okay, because they're pressing that nerve. Real quick, this is not anything that's terribly important, but at least one question may show up about the histological name of the muscles. Okay? Just like we had keratinized stratified squamous epithelial tissue, that's a histological name when you're looking under the microscope. Okay? When you're looking under the microscope at skeletal muscle, the histological name is voluntary striated skeletal muscle. Okay? Because that's the one that you can control. It's voluntary, and it has those stripes. And I'll show you why. Well, let me show you the stripes. Right there. That's what it looks like under the microscope. You see these stripes? That is the alternating bands of those walking arms. In the middle where it's thick, where the walking arms are thick, that's where you get the dark band. The light band is where you just have actin fibers. Okay? So when you see this muscle contract under a microscope, the white band tends to disappear and the red bands come together because the whole thing is getting pulled in.
Wow,
Okay? But this is what's called striated skeletal muscle. Okay? And it's voluntary, obviously, we can control it. Okay? So we'll go back here. Involuntary striated is what heart muscle looks like. Okay? And you'll see that. I've got slides to show you in the future. Your smooth muscle doesn't have striations. It has the same kind of walking mechanism, but instead of being lined up in rows so that you get bands, they're all over the place inside the cell, so they don't form bands. So when they constrict, the only thing, the whole cell just goes like that, okay? But it doesn't have any bands, okay? And so that's involuntary, non-striated, smooth muscle is the histological.
No bands.
No bands, right. And I'll show you pictures later. Okay, the last thing I want to do tonight, on the slides anyway, just talk a little bit about the structure of the whole muscle here. Here's that fascia again, we're talking about that tendinous-like stuff, okay? When that surrounds the outside of a whole muscle, that's called the epimysium. Okay? Myo, or mysi, is a prefix for muscle. Okay? Myology is the study of muscle. Myopathy is muscle disease. Okay? So myo and sarco are two words you're going to see with a lot of muscle names. Okay? But epi, on or above the muscle. Peri, meaning around the muscle. So this stuff right in here, the secondary layer around these fascicles here, that's where the perimysium is. Okay, this white stuff in here. And then if I pull one of these things out and look at a whole cell, then I've got the endomysium here. Okay? That wraps around one muscle cell. Okay? So those are three layers of the connective tissue that you'll see under the microscope. Epimysium, perimysium, and endomysium. And you might as well learn the prefixes because the nerves are the same way. It's epineurium, perineurium, and endoneurium. Okay? And they have the same kind of structure with the fascicles in the cells. Yeah. Around the whole muscle. This one right here. All this around here would be epimysium. Okay? This white stuff in here around this group would be perimysium. And then the stuff that just wraps around one muscle cell would be endomysium.
Because it's in it.
And I'm going to stop there, that's enough. And I'm going to go over the head and eye with you real quickly.
Up above or around. It's on the outside, it's all around the side. Yeah. Wow. Everyone wake up. Yeah.
Epi is around the whole power product. Is around each individual. Yeah. Around each cell. Peri is around the inside of the
whatever you said?
Súper cansado.